Hello and welcome to another math video. Today we are taking a look at our Chapter 2 practice test. We begin with some kind of terminology review. I'm just going to leave this up here. Again, you can pause and take a look to see what is what here in order to, again, just help remember some of this vocabulary that we have. And again, here we have some important formulas. We've got the slope formula, point-slope form of an equation for line, slope-intercept form of an equation for line, and the standard form of an equation for line. Again, you're going to need to be familiar with all of these in order to be successful in the rest of the test. So again, feel free to pause and take a look at these. It can also be helpful if you even just write these out on your own. Again, just writing it can help you remember it better. And here we are getting started on the actual test. So starting with finding the domain and range of the relation and determining whether it is a function. Again, domain is really all of the x values that are covered by the relation. In this case, it looks like our domain values go from -1 over to, it's kind of hard to see what that is. I'm going to call that 4.5. I want to say on the answer key it just uses 4. I want to say that's just kind of an error. Not sure if maybe the graph didn't line up the way that it was intended to. But I would say -1 to x, and then that should be less than or equal to, like I said, hard to tell exactly. I'm just going to call it 4.5 as an approximation. You can kind of count on the test version to be a little bit better in that concern. And the range value of the values, again, that's the possible y values that you have, so a minimum there of -5 and also a maximum of 5. And notice on that relation that there are points at the end of those segments. Those are not lines, so there are points there at the end of those segments. And if we look at the vertical line test, it fails the vertical line test, so this is not a function. Moving on to number 2, we're given a set of ordered pairs for a relation and asked which one we could add that would make this remain a function. So if we look at just the individual things that we could add, if we were to add 5, 8, the problem is we already have 5, 7. So if we add 5, 8, then that would not be a function because then the input of 5 would give us two different outputs. We have 3, 1. Problem with that is we already have 3, 10. So same thing, if we added 3, 1, then the one input of 3 would give us two different outputs. We have 15, 5. We do not have another 15, so that would appear to work. And if we just check out the fourth choice as well, 11, 2, there's a problem there because 11, 1 would again give 11 two different outputs. So the only choice that makes sense there is C, 15, 5, again because we do not have another 15 in there. For number 3 is the relation of functioning, and here's our mapping diagram. Notice the direction the arrows are going. So this doesn't necessarily have to be labeled, but if you wanted to, you could. These are the inputs, these are the outputs, and again you could tell that based on the arrows. So the problem we have here is that 5 has two different outputs. 5 goes to both 8 and it also goes to 4. So no, this is not a function. For number 4, we're asked to find f of 3. So what we do is we use that 3, that is our input, so that replaces all of the x values. Everything else stays the same. So again, it's just this 3 that gets plugged in. So instead of an x in these two spots here, we use 3. Then we just follow order of operations in order to evaluate this, the right side of our function here. When we square 3, we get 9. Now we are able to also multiply this 3 by 3 at the same time because the different terms are separated by subtraction. If we go up here, we see we have f of 3. And then 2 times 9 would be 18, so f of 3 ends up equaling 9. For number 5, we're given the situation about a DVD rental service, costs $18 for monthly membership plus $1.50 for each rental. Total cost is a function of the number of DVDs rented. They want a function rule that models the cost of the rentals, and then they want us to evaluate the function for 11 rentals. Remember, this is really a two-part problem. We need the function rule, and then we have to evaluate it for 11 rentals. I'm just going to use f for my function. I'm just going to use x as my input. So the way the model works is it's $18 for a flat monthly fee plus $1.50 for each rental. So this would be the first part. What function rule models the cost of the rentals? And then evaluate it for 11 rentals. So if I'm going to evaluate that for 11 rentals, use 11 as the input. So 18 plus 1.5 times 11. We get a total of $34.50. And it is money, so again, makes sense to put the answer in terms of dollars for that. All right, next we're looking at coming up with an equation of this line in slope-intercept form. They are nice enough to provide us with the y-intercept of 0.7. So really our b value is 7, and again they ask for slope-intercept form, that is that y equals mx plus b. And they give us the point here, so I would look at counting the rise and the run between those 2 points. So you have 6 for a rise and 5 for a run, so that means the slope is 6/5. We already have the y-intercept. So the equation y equals 6/5 x plus 1, and again in the slope-intercept form like they wanted. Alright, next they want us to graph this equation. There are a few different ways that we could do this. Looking at what we have, I can tell that because of the coefficient on the y, and the value of our c here, because again this is really standard form, that it will have a nice y-intercept, but because of the coefficient on the x and the value of c here, that we will not have a nice x-intercept. So I wouldn't necessarily use the intercept method, so I would lean towards solving this for y and putting this into slope-intercept form. So when we do that, we start by subtracting the 3x. And then we would divide by the -2. We get y equals 3/2 x minus 4. So we have a y-intercept of -4 and a slope of 3/2. So I would plot, first need to plot the y-intercept. Again, we need a point to work from, and then from there we can use the slope of 3/2 in order to get to some other points. It is a fairly large graph. I do like to kind of continue using points until I get to the edge of those graphs. So we've got our points there. We put a line through those points as best we can. Again, it should have arrows on both ends. For problem number 8, they want us to write an equation for the line in slope-intercept form. Passes through -5, 5, and 10, 2. So one of the very first things we're going to need to do is we need to calculate the slope. So if I use 2 as my y sub 2, then I would be subtracting 5. If I start with 2 on top, that means I have to start with 10 on the bottom because that ordered pair needs to be lined up. So I'm going to be subtracting the x coordinate from the other point, which of course is -5. Go through and do those differences. So we'd have a -3 over, really 10 plus 5, so 15. So -3/15, which does reduce down to be -1/5. So we have our slope. Now it's up to us whether we want to, or how we want to proceed from here. Personally, I prefer using the point slope form. I know some people like to use the slope-intercept form. Both work. Like I said, my personal preference is the point slope form. The way that works is you choose a point. I'm going to choose 10, 2 because they're both positive versus the -5, 5. And we fill in our y sub 1, which is our 2, our slope, which is -1/5, and our x sub 1, which is 10. That gives us an equation that we can solve for y to get it into slope-intercept form like they want. Using the y equals mx plus b, we pick an ordered pair. Again, we can use the 10, 2, plug the 2 in for y, plug in our slope, negative 1/5, plug in the 10 for x. This gives us an equation that we can solve for b. Once we've solved for b, then we can plug it back into our slope-intercept form along with the slope. Both end up being about the same amount of work and same operations. If I work on the point-slope form here, then we end up adding the 2 to both sides, and it appears that we have negative 1/5 x plus 4 for our equation. Now this one works out pretty well also. We get a negative 2 here. So you can notice I had to multiply negative 1/5 by 10, so it's really the same thing as we did over here. Then I add the 2 to both sides. We find out that 4 is b. Once we figure out 4 is b, then we have to go back and plug that into our slope-intercept form along with our slope that we figured out earlier. So again, you can do either one. I know a lot of students tend to prefer this method because this is what you're taught early on, because at that point you don't really know the point slope. Although I believe if you give the point slope a chance, you'll grow to like that one a little bit better. Okay, for number 9, they want the equation of a line in slope-intercept form that's parallel to 7x plus y equals negative 2, and it goes through the point negative 4, 6. So first thing I need to do is find the slope of this line. So I would subtract the 7x from both sides. We get negative 7x minus 2. So this has a slope of negative 7. Since we are parallel to that, we would have the same slope. So really this is a fancy way of saying write an equation of a line that has a slope of negative 7 and goes through negative 4, 6. Just like I did with number 8, you could either use the point slope form or the slope-intercept form in order to proceed from here. Again, like I explained before, I do prefer the point slope form, but you should probably do whatever you are going to have the most success with. And so distributing that negative 7 and then adding the 6 will give us our equation. So we end up with negative 7x minus 22. And again, they wanted slope-intercept form, and so that's what they got. Number 10, same sort of question. Notice the big difference though. Now we're talking perpendicular to. So we still need to find the slope of that line. So we would subtract the x from both sides, get negative 2y equals negative x plus 6, and then divide everything by this negative 2, so we get a positive 1/2 x minus 3. Now that minus 3 doesn't really matter for what we are doing. Now this one has a slope of 1/2, so the perpendicular slope to that would be reciprocal would be 2, and then we need the opposite. So a negative 2 is the slope that we're using. Now they also tell us it's going to have the same y-intercept as 3x plus 2y equals 4. This is a little bit of a twist, but really if we can determine this y-intercept, then we can write the equation. There are a couple ways to do this. Probably the simplest one to remember is just put this into slope-intercept form. We get 2y equals negative 3x plus 4. And then when we divide by 2, don't forget to divide that 4 by 2. We get negative 3/2 x plus 2, really. So this has a y-intercept of 2. We have a slope of negative 2. So the equation becomes y equals negative 2x plus 2. There we go. Alright, so number 11, again, this is really our calculator question. So remember your choices that you have for this. One of those choices we can make is to use the actual years for list 1. Again, the other choice you might make would be to have like 1998 be year 0, then 2000 would be year 2, and so on. Really not much choice for the cost. The cost will just be those prices. If you look at the correlation, again, doing the stat plot, again, you might do a zoom 9 to fit the window to the data. And then this would be a strong positive correlation. Again, we can tell that because from left to right the scatter plot is going to go up and they're going to appear fairly close to a line. If you do your linear regression, again you can store that as y sub 1. Remember, you hit the variables key, move to the right to pick functions or y variables, and then hit enter to select function, and then enter again to select y sub 1. So this is at least an approximation for this equation. Remember, if you used 0 for 1998, this will look different, but approximately this for our model. And then you can use the value function on the calculator. Just make sure you extend the window to so that 2020 is on there. And then you should find that it turns out to be about $4.77. For number 12, we need to graph the absolute value function and find its domain and range. So again, some of the things we can tell, the slope as we go to the right of the vertex is 3. The vertex is at -2, -1. So I can start there, -2, -1. As we go to the right, it has a slope of 3, so up 1, right 3. It's going to look like that. So on the other side, we'll go up 1 left, or up 3 left 1. So up 3 left 1. I might have said up 1 right 3. So up 3 right 1. Draw our V-shaped graph. It's going to look like that. Now they also want the domain and the range. Domain for this is all real numbers. There's a few different ways you can write that. The range will be limited. The values of y are limited because this is the minimum. The y values, the lowest point they get to is the vertex, which is at -1. So the values of y are greater than or equal to -1. For number 13, we need to write an equation for this absolute value function. We would want to begin by identifying where the vertex is. So that's at 2, 4. And then the slope to the right appears to be down 1, right 4. So -1/4 is the slope as we go to the right of the vertex. So our absolute value function would have a -1/4 in front of the absolute value. Inside the absolute value we'd have an x minus 2, and after the absolute value we'd have a plus 4. For number 14, they give us a set of transformations to write an absolute value function for. So stretched by a factor of 7.5, shifted 3 units left and 4 units down. So that stretch is really our a value, so 7.5. 3 units to the left would be our h value, so -3, and 4 units down would be our k value, -4. So our function would be y equals 7, oops, not 7/5, 7.5, and then the absolute value, now it would be x minus a -3, so that's really going to be x plus 3 inside the absolute values, and then minus 4. Number 15, we're asked to graph 3x plus 2y is less than -6. I'll take this chance to use my intercept method because the x and y intercepts are both nice. When x is 0, you would have 2y, and I'm just going to use an equal sign, -6, so y would be -3. If y is 0, you get 3x equals -6, so x would be -2. So those are the intercepts, 0, -3, and -2, 0. This would be dashed, so we could dash a line through those points. Those ended up like dots, really, but same thing. Now, a couple different ways to figure out where to shade. You could test the origin, which if you test the origin, you get 0 is less than -6, which is false. That means the other side must be true. Or we can use the trick of looking at our y value in our function. The 2y is less than, so again it's a positive 2y, that would tell us to shade down the y-axis. So whichever way you figure out that, but you would shade this side of that line. For number 16, they're trying to mess with us a little bit by having the 6 over here, so let's show them that doesn't bother us by adding that 6 to both sides. And I'm just going to flip the whole thing around. Notice the y is going to stay on the pointy side of the inequality. So my a value is -1, h is a +1, and k is a +6. So my vertex would be at 1, 6. So that would be here. And it would go down 1, right 1 as we go to the right, down 1, left 1 as we go to the left. This would be a solid line. And again, the y is less than, so I would go down the y-axis. You can also test the origin, which would be true. So we end up shading inside of the V, and if I kind of extend that, try not to get off too much, but again, shading there. And for number 17, we need to write an inequality for this graph. So if we begin, I'm going to zoom in a bit tighter here. Begin by looking at the y-intercept. So that is right here, so that is 0, 6. And if we look for another nice point on there, it is a little tough to tell, but it does appear that it goes through the x-axis here, which is at -7, 0. So from here we go up 6, and then right 7, and it would look like that. So the slope is 6/7. So the equation, so again, I know we're doing an inequality, but the equation would be y equals 6/7 x plus 6. Now we need the inequality, and we need it to go up the y-axis. In order for that to happen, it has to be greater than, the y is greater than, or equal to, since it's solid, 6/7 x plus 6. One thing you could also do is you could take a test point. Now, I don't necessarily like testing the origin here because the origin makes it false and that tends to mess with people's heads. What I might do would be to test the point -10, 10, and that needs to make it true. So if you plug that in, you would get -10, and then here you'd get 60/7 plus 6. So not much question since the 10 is negative and this would be a +10, this would be -60. And so comparing that 10 to -60/7 plus, this would really be 42/7 because 42 divided by 7 is 6. We're comparing 10 to, let's see, this would be -18/7. So the 10 is greater than the -18/7. So then the y, again, greater than, and we throw in the equal to make the solid line. So again, it works well if you just can recognize that it's going up the y-axis, so the y is greater than, and then equal to because of the solid line. And then for number 18, what we'd want to do would be to find the vertex. So that, of course, being right here at 4, -4, and then the slope as you go to the right, it appears to be up 1, right 1 the whole time. So up 1, right 1 for the slope. So slope as we go to the right is 1. So since the vertex is at 4, -4, then h is 4 and k is -4. So in our absolute value equation, again, I'll just do the equation to start, we'd have 1, which I'm just going to emphasize there, absolute value of x -4, and then -4 for the k. In order to get this to shade down the y-axis, the y would have to be less than the 1. I'm going to drop the 1 this time, x -4 in the absolute value, and then -4 there. Again, you could use a test point. Looks like we would not want to use the origin again because that would be on the dashed line. So maybe something like 10, 0 you could test. Again, that way you can make sure that yes, it is supposed to be y is less than the absolute value of x minus 4 minus 4. Alright, I'm sorry, this would actually be, I made a mistake there. So the vertex is actually negative 4, negative 4. That's what I should have had, which then makes this a plus 4. I'm glad I caught that before I was done. You were probably thinking the same thing, like what was I doing? So, yeah, so the x plus 4 would be what we'd have there. Sorry about that. Well, hopefully you found this helpful, and thanks as always for watching.